This is a great question. Evaluate the derivative at 5 if this is my function. Well, if we're going to evaluate the derivative, we'll need the gradient function. So let's just find g dash of r first. What have we got? The bottom. Times the derivative of the top. Minus the top. Times the derivative of the bottom. All over the bottom squared. And look at that. Imagine trying to deal with that algebra. Fortunately, we don't have to. All we need to do is evaluate this function at that point. We're not asked for this in a simplified form. We're not asked for this in factorized form. We're just asked to evaluate it at a point. So after getting to this point where I've got my derivative, whilst messy, it's actually not going to be too hard to work out at this point if we go slowly. So let's just put it in. G dash of 5. So wherever we see the r, we're going to put a 5. So I'll use two colours so you can see where the 5s are. 5 minus 4 cubed plus 1. 3 times 5 minus 6 squared minus 5 minus 6 cubed minus 1. 3 5 minus 4 squared all over 5 minus 4 cubed plus 1 squared. Now have a look how nice this falls out. You can see some 5s minus 6s and 5s minus 4s. So it looks like we're just dealing with 1s really. 5 minus 4 is 1. 1 cubed is 1 plus 1 is 2. 5 minus 6 is minus 1. Squared is 1 times 3 is 3. Minus 5 minus 6 is minus 1. Minus 1 cubed is minus 1. Minus 1 here is minus 2. 5 minus 4 is 1 squared times 3. 5 minus 4 is 1 cubed plus 1 is 2. 2 squared is 4. 2 times 3 is 6. 2 times 3 is 6. 12 divided by 4 and 3. Here's another thing you should try too on your CAS. Type this function in exactly as it appears. From your 2D tab, find your d by dx function, find the derivative. The next step, evaluate that where x equals 5. Should be able to do that in about 3 lines on your CAS. If the question's not asking you to show by hand working, that's a valid and viable option for you.